Hello and welcome to another edition of the Talos Linux Install Fest. I'm Justin Garrison. We are today installing Talos on Azure. So the Azure cloud, we're going to do it with raw VMs, and we're just going to basically walk through our documentation on how it works and figure out all the steps needed to do this in Azure. I need to pause my live stream here in a second because I have a monitor running. Always forget that one. And so for today's stream on Azure, like I said, we're going to walk through the docs. If you're interested in following along, this video is obviously on YouTube. If you're watching it pre-recorded, feel free to follow along. We will have a link to the docs in the comments, as well as we'll show you all the steps that we're walking through, what each step does. And if you want to learn more about Talos, obviously the YouTube channel, we have a bunch of content for you just to watch and see what it does. We're also running TalosCon in London this year. So if you want to come in person and meet us to talk about what Talos is doing or what Sidera is doing, what we do with Talos Linux, and how we can make bare metal and cloud Kubernetes better for you, reach out. It's a lot of fun. For today, my guest, I have Ala. Let's bring Ala up, and thank you so much for joining, Ala.
Thank you, Justin. Thank you, team.
Yeah,
yeah.
I had a confession earlier when we were prepping for this. Is I have never run a standard VM inside of Azure by like running commands. I've run AKS clusters. I've done some toying around of like just the console and what we can do, but I've never had to run Azure in production. So I've never used it in anger, and that's where I usually feel like I feel a little more comfortable and an expert. So in this case, I'm hoping you can teach me a lot about Azure today.
Yeah, you're in safe hand, Justin.
Yeah.
And I will review this installation for the Talos on Azure VMs, and we'll discover the product on Azure and how to use it. Yeah, and interact with it.
Yeah, so I threw the instructions here that we have in our docs on just how to run this in Azure. It's a step-by-step kind of copy and paste commands, and we have to set up some stuff ahead of time, right? Like you obviously need Azure accounts, but there were some things that I didn't expect coming from a heavy like AWS background that I wasn't familiar with. So I was hoping you could help me understand some of that too.
Yeah. First of all, we need to create we can say resource group. This to hold all our resource in Talos. Let's say it's Talos RJ. Okay. And there is storage. Yeah.
Is that resource group? Is that like because GCP has projects, AWS just has accounts. Is that like a project underneath an account, or is that like an account itself? Is that like some sort of boundary of isolation?
Exactly, boundary of you can say a logical boundary. It's only you can create your VMs, Azure Kubernetes, whatever, inside your resource RG resource group. It has like tags and management and anything you want. Yeah, I think it's like accounts in GCP.
Okay.
Yeah, this we will see there. After we create the Talos, now we'll see the resources here. We need to create first of all, we need to create a storage account. Okay, in Azure they call it storage account. I think in AWS, I'm not sure actually in AWS what's called the storage account. It will hold the images, and it has like connection. Okay, connection string to the storage account. You will see it in the demo. Okay, this the storage account should be predefined. This is straightforward, not a big, you can say, deal. Okay, and there is a container inside the storage account. This is some you can read about the storage account, but this is to hold the files and file shares. You can see NFS file shares. You can use it for multiple purposes. Okay.
And that's not is it a different than a container with an application in it?
Yeah,
Like,
exactly.
I was a little confused on this term. It's like, okay,
Yeah.
I was like, why do we have containers already? I'm like, okay, no, this is just like a way to store other things. It's contained in that.
Yeah, exactly. This container is different than container. You can see Docker container. This is called the file container. And you need to predefine container, okay, here inside the storage account. That's it, as required, we can start the deployment. Okay.
Yeah, so we export those variables just as like, hey, we create these ahead of time to make sure we can store things and reference them.
Exactly. We can do it all at once. For example, these all export variables and location. Okay, this is the resource group, and this is the storage account and the container. Okay, and this location. Okay, you can run it in terminal. Okay, okay, that
Okay.
means that's
We got
fine.
the variables. Yep.
Yeah. Then we need to check the connection here to export the storage account connection. This connection is used somewhere else in the script. It's property for the storage account. This is you can see a way to connect to storage account, say like a database connection. Okay.
Yeah.
Also, we need to export this one. Okay, that means it's fine. We can check the connection. For example, we can see the variable here. If we check. This is a variable for the connection. Okay, this is public. You can access from your network anywhere. Okay. Then now it will we will go through the installation for Talos. This is a prerequisite. Now the networking is like creating a VNet. Okay, virtual network. I think this one is used for the infrastructure servers. Okay, for
Yeah.
the worker nodes and master nodes. Yeah.
And most of this, so we in the docs we're using the pre-existing images that
Yeah.
Sidearrow publishes into Azure. So we're just setting up the network connections here of like
Yep.
how are these nodes going to talk to each other. And if you use
Mhm.
any cloud environment, it's heavily restricted, right? It's like deny first and then allow
Yeah.
different things, right? So we have to say like, oh, we want the two nodes to be able to talk to each other for etcd, to talk to the Kubernetes API, that sort of stuff, right?
Exactly. Yeah. So we'll create the virtual network here. This inside the resource group location, and there is a name VNet, Talos VNet, and there is subnet. We'll check that later. Okay, let's create this. Mhm. Now it's done. Okay, the success means success. Okay, now we'll create the NSG. NSG is secure, not network security group. This is like the it exists in all cloud provider. Okay, on terminal.
I'm already a fan of these names. Like I like
Yeah,
VNet over VPC. I like that it's called a network security group, not just a security group, which is
yeah,
very confusing in AWS.
yeah. That's good. Yeah,
These names are clearer to me
yeah.
as a new person.
Yeah, here we are creating also a rule inside the NSG. Okay, so it's straightforward. This rule, priority one, actually, whitelisting some ranges. Okay, some port ranges 5,000. Okay, inbound. Okay, we'll
And
check that.
that one
Yeah,
specifically, so the 50,000 port is where the Talos
yeah.
operating system API listens. So the Talos as
Okay.
an OS doesn't have SSH. You would normally open like 22, right? Like I need to call port
Uh,
22 to SSH into it. Talos has an
mhm.
API, and that API listens on port 50,000. And so that's the one that
Okay.
is available to
Yeah.
like send config files to and say, hey, I need you to do stuff. That's how you do it to Talos.
Okay. Yeah. This is the port. Actually, this is the port inbound port, and this also inbound rule to whitelist 550,001.
Yeah,
Okay.
and 50,001, I think it has the name in there, right? Trust D. So
Yeah.
Trust D is the way that when a node joins a Kubernetes cluster, it creates a certificate request, and the certificate request has to be able to
Okay.
call an API and say, "Hey, here's my cert. Please let me join," basically.
Yeah.
And in 50,001 is the port that the Trust D daemon, which is doing that certificate signing for trusted
Okay.
nodes. Like, oh, yes, you're allowed to join this
Mm-hmm.
cluster. We don't do that through the standard Talos API. That's a Kubernetes API or a
Yeah.
Kubernetes component of certificates.
Uh-huh. Okay. This is also another range of ports. 237. Okay. This all attached to the NSG, same NSG.
Yeah, 2379. That's standard etcd for the database.
Yeah.
Those and
It's
in
CD,
this
yeah.
case, we're running a highly available 3-node control plane, right? So we have 3
Yeah.
etcd nodes with API servers and all that stuff. So we
Okay.
need all 3 of them to be able to talk to each other.
Yep. This API. Okay.
Yeah, Kubernetes API 6443. That makes sense. That's where
Mm-hmm.
Kubernetes API generally listens. I wonder
Yeah.
why they picked 6443. I was like, I know 443, but why 6
Yeah.
and not 8443, like 8443 would have made a lot of sense to me, as Kubernetes has an 8 already in it, and I
Yeah,
don't know. I wonder. There's a ticket somewhere where someone did this. I bet.
yeah, exactly. This also creating the public IP. Okay, this we'll see it later. Okay, this load balancer. Mhm. This is just a warning about the breaking change in future.
Okay.
So this is created a public IP. This is the public IP address. Okay.
And we said that as
Uh,
static, so we have this one
yeah.
IP, which is going to be our
Uh-huh.
load balancer for all of the control plane.
Exactly. And this are now creating the load balancer. The load balancer will reference this IP. Okay.
Hmm.
Will reference this one created before. Okay.
That's interesting. It does it by name, not I'm used to AWS and like everything is tag based. So you have to label it,
Okay.
and then you look up the labels, and then you reference the labels, and you're like, no, just straight up names. Like you can name it, and
Yeah.
then
Exactly. Yeah, you can reference by name. There is backend pool. Okay. We'll see that later. How to now there is a backend pool for this load balancer. We'll see that. I think it will attach to the master nodes here. Okay, this is done. Okay, create health check. Okay.
and that health check's looking at 6443, which makes sense because that's
Yeah.
again looking at, is the Kubernetes API available in this node? If not, take
Yeah.
it out of the load balancer.
Yeah. Exactly. Okay, it is done. Create LB rule. Now there is a rule. Okay. Load balancer rule. Health check and load balancer rule. Protocol TCP and the backend pool. This only to create a backend pool for this port. Okay. Yeah, it is done. See here, there is three. I think there is three master nodes. Okay. There's for loop for three master nodes to create NIC card and create public IP for each of one. Okay.
That for loop goes all the way down. You'll need to run it.
Okay. Yeah. Yeah. Sorry.
Yeah.
Yeah.
There you go, all the way to done. There you go.
Actually, this is public. Okay. So maybe customer will ask you in future. I need private IPs for the master nodes. Okay. Run terminals. I think these are public, right? Public for the control plane. Yeah. So it's done. Okay. Now
Yeah,
first one
I
is
actually
done.
I actually do wonder the reasoning for making, if we have the load balancer. I mean, we could
Yeah.
do individual Talos control commands against those public IPs
Yeah.
instead of going through the load balancer, which I know has some reasons you might want to do that. But I have to look that up.
Yeah. I think all done. Maybe here. Let me check. Oh, okay. Still maybe
Still
doing
doing
the
the load.
last one.
There you go.
Okay, here you go. This done. Now, note. Okay. This is LBIP. This is the load balancer IP. Okay, let's do this command.
Yeah, we're just saving that as a variable now that we have the load balancer
Yeah.
created. We have an IP on it, because that's the next step, is this gen config, which is
Yeah.
you need to create the config, and that's going to create certificates, and those certificates need to be
Ah.
signed with that
Okay.
public IP address, so that we can
Okay.
trust it.
Yeah, exactly. This Talos command. Actually, I installed this Talos CTL before. So maybe if you want to do it in your lab in Azure, you need to install it. You can do it, no problem. Yeah, I did this one before. I
Oh,
can
so you have the files
force it.
exist. Yeah.
Yeah, dash force. Okay, this is generated some file. Okay, control plane and worker and Talos config. Okay. Now the architecture. This we need to export these variables. This is used later, okay, for the VHD, I think, in the image.
Right.
And this one is now creating the VMs. We started creating the VMs, the availability set. Okay.
Is that like a auto scaling group in
Exactly.
AWS?
Yeah.
Okay.
Yeah. It's like VM scale set or availability set.
It's a group of VMs that use the same
Yeah.
image and same configuration.
Exactly.
Okay.
Yeah.
And because that's where the next step is, you're creating 3 as part of that availability set.
Yeah. Exactly. AZ VM create, name image, admin, for example. Yeah. You can see here it is referencing the availability set we create before. Okay.
Right.
Now we create the 3 VMs for the control plane. This is the gallery. Okay. Image gallery, and it's already uploaded to Azure. This one is already there, so no need for to worry about it. Okay.
Right, because we
And
publish those images whenever we do releases. You could specify your version there. If you want to publish
yeah,
a custom image or
yeah,
configuration or extensions or something else, you would have to publish that yourself. But like there are steps in the docs to do that too. We're just doing this as a getting
so
started.
for yeah, so I can, for example, do customization in my Talos image and do it and upload it, right? Use it in Azure.
Yeah, and you also could is like you could pre-upload the image, or you could do something like a Talos control update with
Yeah.
a custom image later and say like, oh, I want, we're doing it with the vanilla image the first time, and then when we're doing an upgrade, we want it to have some customizations or something in the image itself.
Oh yeah. See, there is some just accepting the terms of license agreement because it's like a community.
Right.
So I need the, yeah. I can use this command accept term directly. Okay.
Oh, and I was reading. I'm following along on the docs as well, just because that's
Good.
the control plane. We just name them 1, 2, and 3, and so it's highly available. Do you know? Does a availability set automatically spread that across availability zones, or is that just like is there placement constraints on that?
Yeah. There you can choose actually this where to land these VMs. Okay. I think there is default landing zone 1 and 2 failure domains and update domains. But yeah, I think we'll check that in the portal after that. But yeah, there is a good question about the high availability.
Right. If
Now
we're
we're
making
creating.
3, if we're making 3 and we put them all in the same
Yeah,
AZ, then
yeah,
what was the
no,
point?
no, yeah. Create a worker group. This is the worker node. Okay, this is a worker node. Here, this some parameters for the worker nodes. Okay.
I
Here
think it's
just
funny because that command even has the generate SSH keys as like a
yeah,
flag, and like that's just
yeah,
like
here.
it's so ingrained into every
Mhm.
cloud and every Linux distro that like no, the way you do this is SSH. It's like, well, like maybe what if you didn't, and that's still
Mhm.
part of
Yeah. Here, just asking Justin about for example, if I need to scale my Talos cluster after that, I need to create from Azure one another VM, or this you can do it from the Talos CTL or something like this.
it.
Not
In this
sure
case, yeah,
actually.
you would do it from Azure. So like if you wanted to
hmm
have an auto scaling worker node group, you would
hmm
make another availability sets and then add
Okay.
worker nodes to that. And I'm assuming you just scale the availability set and say like, oh, I want 10, and it automatically
Yeah.
deploys them. I don't actually know that side. But I think that's what you would do. That's what you would do in AWS,
Yeah.
right? You make the ASG, you say create the ASG with this template, and then give me 5 nodes, and it would just
Yeah.
stamp them
hmm
out basically.
This is a control plane IP. Okay. We'll take the IP now. It will be used later. Okay. Run in terminal. So we'll come now to the Talos CTL commands. Okay. I think you can explain these commands, Justin, here.
And those two commands, those are setting your config file. Those are setting settings in your config file. They're not actually running it like somewhere else, because we're sending, hey, we have this Talos config file locally. We want to put the endpoint as this control plane, so that anytime we're calling this cluster, we're going through that endpoint, and the one node we have as going through there as well. So that's just setting those settings in. Like if you open the Talos config file, you'll see those as options now.
Yeah.
It just saves you some steps whenever you're running commands against it in the future.
Exactly. And this is the last one, actually, this bootstrap command. Okay, great.
And Bootstrap is creating the etcd database. Like that's, we have
etcd. Okay.
the VMs are available. They're told that they're control plane nodes. We need them to run Kubernetes API stuff.
Okay.
But until all of the nodes are ready and available, you don't want to start etcd, because etcd needs to know what peers it has and needs to say, oh, this is who I'm going to talk to and allowed to talk to in my database. And so that Bootstrap command is just creating the etcd database.
Okay. And this is the last one, which is generated config file. Okay. I don't know. Okay, there is another one, generate configuration file. Yeah, it is, I think the same.
It looks like it.
And I will copy my the generated one. This will be now here. Okay, there is a kubeconfig file here. I will copy it to the default one. Okay, let's check.
No nodes yet. Where's it? Is it calling? So a couple things we can do here is we can Talos control. Try Talos. Where's your? You have your Talos config. So Talos control command, and instead of running the kube config there, run dashboard. I wonder what it will hit if you. Everything.
One, you
get the Talos config part too.
Yeah. Now start coming.
There you go. So they're booting up. So when you run the bootstrap command is when like nothing is available yet until you say I have a database. And so everything up until the bootstrap command is just like, hey, we're ready to go.
Yeah.
But it's not available yet. It's because once you run the bootstrap command, then everything says, okay, now we're going to actually run all of the components. etcd needs to reach quorum so that it knows which node is the primary and which ones are secondary. Say, okay, those are going to reach quorum, and then the Kubernetes API can start up, because right, like Kubernetes API is just like, I have no etcd, I can't do anything yet. So until it's available, it's not going to start doing anything. So Kubernetes API is going to come up, all three nodes, and like they reach ready, they pull down images for things like the scheduler, controller manager, Kubernetes API. So now if you do like a kube control get pods -A, you'll see the defaults of like what pods are running in the cluster.
Yeah, you're using Flannel actually and Core DNS. Okay, that's all fine.
Flannel's the default CNI. You can see that we have 3 controller managers, 3 schedulers, because that's how many control plane nodes we have, and those run as inside the Kubernetes cluster. You can see the logs and do all other stuff from them. So that's all available. Flannel, we have no workloads, but we have the default like kube proxy for the node, the daemon set that runs, and core DNS.
Okay, now it seems this. I just want to test this kube scheduler. Okay, we can show you this this one in the resource group. Okay, this is the resource group for the Talos. So you see these objects we created in the scripts. Okay.
Can you make that a little bit bigger?
Yeah. 1 minute.
If you can control plus it, or there you go.
Yeah.
All right.
Yeah, this is the here this control plane virtual machine, okay, disk. Okay.
Wow, so that's literally everything is in that overview. Okay.
Yeah. And this the for example, this is NSG. Okay. And the storage account was created before. You asked me about this availability set. Okay, let me check this one.
Yeah, curious if that automatically spread that across different AZs. I know it's all in central US
yeah,
region.
yeah. See, fault domain is 2, update domain 5, virtual machine is
Okay.
3. Yeah, I think this can be, yeah, it is doing this by default. You know, this for example, for the first node, fault domain 0, update domain 0, and this one is 1 and 1. Yeah, it's the default values. Yeah, but it's, managed behind the scenes.
Right. So that availability set's doing what we would expect. That's good.
Exactly. Yeah, and this is the one the rules we added in the script. These names, the sports. Okay. Yeah.
So if you go back to your terminal and
Yeah.
export, run export Talos config in all caps.
Export. Talos.
Talos config, one word. And then equals, and then you'll need it no spaces between if it's, I'm assuming you're using bash.
Yeah.
Equals and then /Talos config, the file that we have in that local directory. Yep.
You mean this one? Okay.
Yep. And then run Talos control dashboard. That's just setting the config file, and then we already have the endpoints and the worker node in there. So if you run Talos control space dashboard, I think it will automatically pull the dashboard from one of those nodes.
CTL. Talos CTL, right? Talos control dashboard, right?
Dashboard. Yeah. Okay, cool.
Okay.
It does just work. That's good. This is, and it's pulling because we set the node to I forget what IP did we set? The control plane IP. So one of the interesting things here is like this is on control plane 0, as you see in the top left corner. But we have 3.
Yeah.
If you wanted to specify a different node, you could do a -n and then the other Talos control plane 1 or 2. But that gives you like some information about, kubelet API server, like the lower level things that you're like, oh, what's going on? This is kind of like SSHing to a node and running htop a little bit. You don't have to do it this way, but it's one of the things that literally, if you go and look at the console in Azure, this dashboard board will be running locally as part of the VM, but we can pull it up over the API.
Yeah, that's good actually.
So you can control C out of that, or I think is it Q? I don't remember.
Yeah. Control C.
And then if you do something like Talos control reboot, we'll literally just like go tell that control plane node, like restart yourself, and it should come back. That's going to be control plane 0, and it's going to wait for it.
Okay.
But if you open another terminal, our API is still there, right? Because we have three APIs behind the load balancer.
Yeah.
You did pull.
Yeah.
By doing this, we pulled an etcd because etcd is running on the control plane too. So like etcd gets pulled out, API server goes away, one of the controller managers. So if you open another terminal and get your kube config and look at it, you'll see one node is unavailable. You'll see one replica of the API server is down.
Sorry, this
kube control.
Okay. Yeah. Okay. Yes, you're right.
Yeah. So there's 0 is not available, but you're still hitting the API, right? Like that's when we look at the dashboard, we got it. But and if you look at the all pods, you'll see that like one of the pods for each of the control plane components would be unavailable because we just told it to go away.
Yeah. Yeah. Exactly. Yeah. Completed this one. Okay.
There's an error on controller manager and terminate. That's weird. It has 3 different statuses for what happened: terminated, error, and completed.
Yeah.
I wonder why that is. But those are like some of the basics of like, okay, we have a highly available. So like upgrades, all that sort of stuff. Like if you want to change your image, and say like, oh, we want to do a different image, we could try that. If you, I don't know. There's a lot of things we could try here, but like right now we just have a Kubernetes cluster. Like that was pretty easy enough if you know Azure and you know some of the basics of the.
Can I deploy a sample app, for example? Sure. I have sample app. Okay. Apply.
And one thing that's missing here is we don't have any of the cloud controllers. So if you deploy a service that says it needs a load balancer, you're not going to get that
Okay.
because all the cloud controllers are separate components. Like you have to integrate
Okay.
those as separate things to get an Azure load balancer for an application.
Yeah, I need to see it actually. There is an application. Actually, I have a sample application to spin up ingress controller, and I use it for testing. Okay.
So if we want to, like the cloud controller here, I've put it in chat, but you're not going to get a load balancer until you have something like the cloud provider for Azure. But in order to do that, you're gonna have to set permissions on that pod to be able to do the things in the cloud environment for IAM or whatever it is to.
So not automatically deploy talk to the provider, right?
Yeah, we could try that. Where's
I mean, this service should okay. Yeah, now it's okay running. Okay, but should get services should yeah, for example here should get external services. Kubernetes. Okay.
So you have cluster IPs, but no load balancer requested.
Yeah, I'll send you this sample. Okay, in the chat. Yeah, it should. There is a load balancer. There is ingress actually. Okay. No, there is ingress here, but there is no IP. Yeah, should get a public IP here. But yes,
Right,
there is
and we
no
won't.
managed. Yeah.
Yeah, we won't get that until we have the cloud controller manager running.
This is an extra step, you mean, right?
Yeah.
Mm-hmm.
So I mean, we could try. I don't know the permissions needed for that. I'm actually I'm looking at the README right now, seeing where you set up permissions, because the cloud controller manager is going to run in the cluster. It's going to be a component that says, "Hey, I need to create resources inside of Azure."
In the cloud.
And but it needs to have the permissions available, and I don't actually know. I guess you could like make a static IAM permission. There's images made. AKS matrix.
Actually, some Azure customer using AKS engine. It is the same idea, okay, for the Talos. But yeah, AKS engine is somehow used by customers. It's used in on-premises on Stack Hub. It is same, actually similar idea, but for Talos, maybe there is new legacy. It's somehow discontinued in some okay.
There's a cloud controller manager app. Oh, maybe not. I'm trying to read the CCM deployment docs, and it links to dead pages in GitHub. I'm trying to figure out how it goes.
Yeah. Yeah, I was asking actually. I was thinking about deploying a sample app, but yeah, it's good you clarified that it's not straightforward.
Right. So I mean, the extra things you're going to need there is like if your sample app, if your registry requires authentication, we obviously need to add a secret to say we can pull this image. That's a simple enough one. But yeah, in the environment of I need to now authenticate this controller manager to the rest of the cloud, I need to basically give it admin permissions in a lot of cases, because it needs to do a lot of stuff, because sometimes they do like
provisioning,
load balancing, new security groups, whatever. Like it does a lot. And I don't see anything in the configuration docs of. Oh, okay. Here's an example JSON. I see. And you have to specify. So we would have to make tenant ID, AAD client ID, subnet, security group name, VNet name, resource group. So we would be basically taking a lot of the configuration that we just did and putting it in this JSON file for it to pull in. Okay, yeah, that would probably take a little while, and I don't know all these steps.
Yeah, exactly.
but that looks like
Yeah.
where it's going to get any of its
Azure
permission.
SI, yeah.
Here it is in the, I'll throw it in chat just so that people can see it. But that has all of the like things you would need, that almost all of them are going to be specific to your environments.
Yeah, exactly.
But yeah, that one would probably take a little while to
Cloud
get it
tenant
up and running.
subscription. Yeah, it gives like yeah, I get your point. Get this will give like Azure CFG file. This will have some credentials and application to in order the
Yeah.
cloud controller talk to the Azure. Yeah.
And for a lot of like reason, like this is basically what AKS does for you, right? Like because AKS is
Yeah.
going to
Exactly.
create those nodes, the highly available control plane, and get things ready, and then also install the cloud provider, the controller manager,
Yeah.
with all of the right permissions, because it knows that
Exactly.
about your account and everything.
Mm-hmm.
So when you're running AKS, you're getting all of that stuff by default. When you're running any other version of Kubernetes on top of a cloud
Yeah.
environment, you need to integrate Kubernetes into that environment. And that's what pretty much every one of the hosted Kubernetes offerings does, is
Yeah.
they give you that
Exactly.
integration.
Yeah, I sent you in the chat. What is this? I found also. Yeah, but also I see this somehow similar idea in the AKS engine. Okay, maybe you can check this product.
Yeah. Let me see. What is it? So is the engine here? I was gonna, let me put that in the public chat. AKS engine provides a command line tool to bootstrap Kubernetes clusters on Azure and Azure Stack
Yeah,
Hub. Okay.
it's somehow similar idea here because
Yeah.
it's remind me of the same, but actually these stuff, these commands, it was like scripted inside a command. Okay, inside the AKS engine, there is a command az AKS engine install, and you can specify the number of, for example, these control plane, whatever. It was easy to set up. Okay, but yes, somehow similar idea about that. Yeah. For example, here in Windows. Okay. Yeah. See, this is the one. Okay. I'm checking this, but it's out of the topic. But just yeah. Install disconnect environment. Yeah, this is deploy cluster. Okay.
Yeah. I'm following along. Find
Yeah,
cluster.
this is the JSON file. I think
Yep.
this we need to fill the JSON file, and
Yep.
then this is a cloud provider. I think this is the same idea in Talos. There is like connection to the cloud URL, cloud provider URL, and you need to create application with user. Yeah, this is for example user for Windows, and that's it. Yeah, but after that you will see the resources provisioned. Yeah, the same idea.
Yeah. Interesting. So yeah, that's like I know in AWS there's a tool called Cops that's
Yeah,
often
caps. Yeah,
used. Yeah,
exactly similar.
it's a very similar thing, but like a first party version of that, where it's like, hey, if you want to bootstrap this outside of AKS as a
Yeah.
service, you can, and it gives you all those steps.
Yeah, exactly.
Yeah, and there's your client secrets for permissions and subscription ID. Okay, that makes sense. All right, but yeah, that's definitely something that we would want to have as more easy to kind of integrate in those environments of like, hey, well, how
Yeah.
do we, let me go ahead and pull up the thing, the cloud controller managers, those are, because they're not integrated into the API anymore. They used to be back at like Kubernetes 1.13, I think might have been the last one, maybe 1.14.
Yeah.
They all used to be part of the Kubernetes controller manager, where it would actually do all those permissions for you. You didn't run a separate component, but in general, that just was a lot of maintenance for like the Kubernetes as a project to like try to maintain every cloud environment that wanted to be part of it. Because originally it was just GCP, and then it was like GCP and AWS, and then Azure, and then it was Oracle and DigitalOcean and all these other ones. And so it's like, okay, this is going to grow to infinity. We need to stop doing that.
Yeah.
And splitting out all these cloud controller managers. So,
so most customers for Talos Linux installing on premises.
Yeah, that's a primary edge and on-prem is where we get a lot of interest, especially it's like, oh, well, we have, very specific needs for where it's running, how it's running. We have investment, whatever, in data centers and colos, or just the spend, or when they want more control over it. And so a lot of the customers for Talos are like they're on-prem primary, and then they burst into a cloud, and they're doing that with something like, you know, the Carpenter on AWS side, or Cluster Autoscaler for just like a generic, hey, just create me a new node. But then that also needs to have a cloud controller manager in that environment that can say, okay, the Cluster Autoscaler can create the VM, but any other networking or load balancers, if you're trying to create those in the cloud environment, you have to have something like this.
Okay.
But I mean, I was thoroughly impressed that the docs were mostly painless.
Yeah, nice.
And I appreciate you walking through all those steps.
Most welcome.
And one thing I do see that's missing from this is like how to actually like turn all that off. Like I don't know, I don't know the correct steps to delete the cluster now that you've created it.
You mean the resources, right?
Yeah, all of the resources.
You can delete it. Yeah, exactly. You can delete it by, for example, from portal. Okay, or you can from command line. Yeah, we can take it from portal from here.
Like if you delete that resource group, will it automatically be able to clean up everything?
Yeah, clean everything. Yes, exactly. Even the storage account, everything. So if you want, we can do it. Okay. Resource group.
Are you sure? Are you really sure? You're
Okay.
And now we watch things go away.
Exactly.
Yeah.
But it was good actually. Yeah. I mean it's new version 1.130, which is new Kubernetes, right? The version.
Yeah.
It's brand new. Yeah.
Yeah, we usually a lot of the Kubernetes versions, like new versions, go with new Talos releases. Like we couple them like within a range of how many versions of Kubernetes we support per how many versions of the OS, because they're so tightly coupled. Like as far as like being able, it's a single purpose OS. So it's like you can get Talos 1.6 with all the way up to I think like Kubernetes 128 or something, right? It's like, okay, we have a range of Talos 1.6 supports these versions of Kubernetes. You're using Talos 1.7.5, which I think is the latest in anywhere, but that has the latest version of Kubernetes available. So.
But for each, I mean, in your company, for each provider, you are managing these resources. I mean, patching and uploading this images. It's a headache. I mean, right? For example, for this Azure gallery, for this Azure image, and for other stuff, right? You need to maintain all these bug fixes and testing, right?
Yeah, I mean, because the OS is so minimal, there's fewer things to patch, right? I mean, if there's only a dozen things in the OS, like you don't have to patch hundreds or thousands of things, which is really nice. For the Kubernetes side, like we follow. Yeah, there goes your load balancer.
Yeah.
For the Kubernetes side, I mean, we're following releases. So as soon as there's a release outs, we're running through our test suite of, does this work with the OS? Is there a new thing inside of Kubernetes that it needs from the OS, and then we're validating those things as part of our build process and test process. And then we're publishing the images and updating. In most cases, it's like metadata updates for like, oh, this version of Talos now supports this version of Kubernetes. We validated all of our tests for it.
But you didn't have like your own Kubernetes flavor, right? Or some custom Kubernetes upstream, right?
Yeah, we're not rebuilding Kubernetes as part of it. So if you even look at like most of those images that get pulled down come directly from the Kubernetes, the official registry.
That's good.
Yeah, so it's official upstream images. You can specify custom ones, but by default, it's just we pull we test against the upstream and we reuse the upstream. So
because in Azure it's a headache for because the AKS is somehow our Kubernetes version from there's a lot of bug fixes and work behind the scene done by the team from Microsoft.
Yeah, and even like at AWS, they had a thing called EKS distro, which was like literally the flavor of Kubernetes that they would build internally. And EKS distro is what all of the EKS products were based on. And ideally, that was for like they could patch faster or release bug fixes and backport things. If you go look at EKS distro, I think last time I checked, it had like 4 patches, and 3 of those patches were to like work better on a Mac. And it's like this is for like development purposes. This isn't for like a production use case. So like EKS distro was kind of like this. It was a lot of work for minimal sort of benefits. Yeah, you can see the EKS distro was like that was it. It has all these things that it says it does, and if you go look at the actual code, it's like, oh no, the patches are like pretty minimal. Like, this isn't doing a whole lot. You're just rebuilding it and basing it off of something they control. Which is what a lot of big companies need. Is they like, we just need control over this open source aspect of it.
So, just asking, customers are opening, for example, support the tickets with you, supporting their application, for example, in terms of slowness, whatever, and there is bugs or some problems, or you are you're giving support to this in Kubernetes level or only in infrastructure level?
Yeah, I mean, we'll support Kubernetes down to the kernel, basically, right? Like that stack of like, hey, we have the OS and the Kubernetes aspect of it. We run a lot of our stuff on Kubernetes as well. We have a hosted version of like a better provisioner called Omni, which is just like all of those steps you ran manually. Like you could do some of that automated and get it to connect back and manage the clusters. But yeah, when customers are asking, hey, we have this problem, we need something. We have a couple different ways that like not automatically, but allow them to get around the issues they have. Usually we have what's called extensions, which are kind of like packages where you can install a service at like the lower level of the stack. And then we have overlays, which are for a lot of people use it on home labs. We don't have like official support for them, but for like Raspberry Pis and things of that nature, where it's like, oh, I have a specific board or specific hardware, how do I customize the Talos installer? And so we have overlays for those sorts of things. But yeah, we build all of those. So like everything, like the Linux layer is where Talos lives, and in anything below Kubernetes, we absolutely control all of that. Anything the Kubernetes API and above might be a bug in Kubernetes or it might be a bug in the environments, but we have a pretty wide variety of where people run it. So like I did a stream last night. This laptop behind me right here is like, that's running, Talos. Because it's just like, oh, it's a spare laptop, let's run it. And it's actually connected to the person who did the stream with me. It's connected to his control plane cluster, which is like 1,000 miles away from me. So it's like, these are like, people do these sorts of interesting things when they're not constrained by an environment. And so we get a lot of that, like, hey, we're running this in the closet in 1,000 stores. We wanted to do these things. Okay, well, let's figure it out. And some of those are Linux problems, some of those are Kubernetes problems.
Yeah, I can see now the resource group now vanished. Okay. Yeah, that's it from Talos.
We're all cleaned up?
Yeah.
Cool. Awesome. Well, thanks again so much for running through it with me. I mean, it was pretty painless for just running the steps. It was more it's always more Azure in setup steps than it is like Talos steps. But it's like at the end of the day, we kind of have a cluster. I'm going to make a note that we should have cloud controller manager docs and examples, especially because we can have those. Like
that's good. Actually,
the configuration you already have in your shell right there. You have all of the steps you need. You need to set up a couple different permissions, and then at that point we could have 1 or 2 extra commands. Oh, now we need to install the controller manager. And
exactly.
And you'll be ready to go with a load balancer and ingress and all that other stuff.
Exactly.
Cool.
It was smooth, actually, and they call it demo god helping us.
This was great. So thanks again, and thanks everyone for joining and watching, and we'll talk to you again soon.
Thank you.